All right, this is section 4.9, antiderivatives. You're looking there, page 274. Okay, yeah, assume the position. All right.
Yeah.
All right, so let's talk about it. You know how to find a derivative. Let's look at a particular function, f of x equals 2x to the third plus 3x minus 7, correct? And how would you find the derivative of this, Weston? So we mark the derivative as f prime of x.
You take 3 times 2, which is 6, drop the power by 1, so it'd be x squared, and then you do the same thing throughout. So
Okay, so what do we do here, just to make
it'd be just plus 3, because x to the first power. So,
okay,
and
so,
then 7 doesn't have an x, so it becomes 0.
okay. So what you do is you take the exponent times the whole number, and then lower this one. All right. So let's say if I was to come in here and say, all right, the derivative of something is 6x squared plus 3. Can you find the original? Can you find the original f of x?
No.
So how would you do that?
Damn it.
Okay, so in other words, I want you to find this. Now you
Yeah.
have it here, but how do you
Dang
find it? I know you know
I thought
what
I
it
did
is.
a good job.
It's like 2x cubed
It's
plus
right there.
3x minus 7, yeah. But how would you get it?
Oh wait,
How do you
If I
get?
did
how do you get the
Yeah, you
7?
can't get the minus 7.
Okay,
Or
we'll
the
just
first
get the
part,
first part, and then we'll worry about
Okay.
that.
So
2x cubed.
6 divided by,
6 divided by the exponent.
by
The
3.
coefficient divided by the x.
By exponent plus 1.
All right.
3.
So the exponent plus 1.
Yeah.
So we would take 6, and we would raise this, we divide by that, and then it would be x to the third. Would that give us this?
Yes.
Yes, so that's good. So then what will we do with this?
question.
3x
3x to the first.
Divided by
1.
1, because what's
It's
the exponent of,
One.
the exponent of x right here is 0, so we'd raise it up 1. And that would give us this.
Yeah.
Okay, now we cannot come up with that, can we?
You gotta add.
So we would just add a constant. We don't know what it is.
Oh, handy.
But we could come up with this, so you would say 2x cubed, if I simplify this, plus 3x plus c. And so we would say, well, the function has to be this. We just don't know the constant, right?
Right.
Okay. All right, so what did we do?
Reverse the process.
So like if anything is x to the n, what would you do to reverse it?
N plus 1.
Okay, we go
x
to
plus
the
1
n plus 1
divided by n plus 1.
divided by n plus 1, is that right? Well, let's look here.
Divided by n.
Well, let's look here. We took it divided by n plus 1, which is 3, right? And we raised it to the same power. Okay. This is a rule that you came up with. This is called an antiderivative. This is called an antiderivative. So we're reversing the process. All right? All right, so what I'm going to do is I'm just going to throw some derivatives at you, and I want you to find the antiderivative, which would be the original function. Okay? All right. So we would say find the antiderivative. Did I spell that right?
Yeah, sure. Good enough for the girls we go out with.
Okay. I see you're fired up today. All right. So the derivative is x plus 8. All right. Would you write down what you think the antiderivative is? Not the derivative, but the antiderivative. All right. What do you got, Gavin?
1/2 x
squared plus 8x. Plus c.
Plus C. Now, I will warn you that there was like 6 of these on the test, and I actually had somebody miss all of them because they forgot to put plus C.
Oh.
So you've got to remember to put the plus C, because you don't know what that is, right? What's another way to write this? Could he have wrote it x squared over 2 plus 8x plus C?
Yeah.
Either one is fine, okay? Just showing you a different look here, all right? So let's try, yep.
So do you just assume that there's gonna be a constant in every one?
Yes, yes, but the general is that there's a constant. Even if that constant is 0, Dane, there might not be a constant, but C can still be 0. Yeah. And it stands for a positive and a negative, doesn't it? Okay, Cheney, do you have a question?
No.
Okay.
It does.
All right, let's see if you can do that one.
You get the last term.
Thank you. I don't know what has gotten into you today.
I don't know either, Mr. Ellis.
I'm gonna have to erase this because okay. F of x. Who's got this one? This first term.
1, 6, x to the 4.
X to the 4. So you're gonna divide by 4, right? Let's see that. 2/3. I'm gonna do that as off to the side here. Let's do it over here. So she took 2/3 divided by 4, right? Which is 2/3 times the reciprocal, right? Which is 1/6. You agree?
Yeah.
Okay. Plus, what's this one?
5/3.
Third. Okay. Minus
1/4 x squared.
1/4, because you divide by 2, right? 1/2 divided by 2 is the same as multiplying. Plus
7x
7x
plus c.
plus c.
X squared.
Oh, this is squared, right? Yep. See how easy though it is to mess up one thing.
Oh,
I already forgot to write the plus C.
See?
I told you to do that at the very beginning, Weston.
Okay. You didn't see that?
Might as well get some credit.
I don't think that's how it works.
There's a parenthesis.
Okay, would you do that one?
It's supposed to be F prime, right?
This is F prime. So what should you do first? You should
Foil it.
foil it first. You should foil it first. you get that when you followed it?
I can't.
Yes, I did.
It's just a negative one.
Okay,
This is
so
where I get confused.
what did we get here?
2x cubed
Okay, 2x cubed,
Mhm.
plus
okay, because you raised up, divided by 3 plus
3 halves x squared
3 halves x squared
plus negative 45x.
plus negative 45x
Plus the C.
plus the c. Alright, let's go up here. The derivative is 3 squared x minus the fourth root of x to the third. What should you do first?
Change it to exponents.
Alright, so this would be
3x to the
1 half, right? Minus
3/4.
X to 3/4.
x to the
4/3.
Three
Or the 3/4.
fourths.
Okay.
3/4.
I always get confused on that.
So that's the original, right? Now what you have to do is put it in the right form.
Okay, so when we raise up a fraction 1/2, or 1,
Uh-huh.
Make
it's
3
2
halves.
over 2.
You have
1/2.
1, which is 2 over 2,
Okay.
which is 3 halves.
Okay.
Okay? So the first thing is we have to raise it up 1, which is,
3x to 3 halves.
yeah, to the 3 halves. 1 half plus 2 halves is 3 halves. So we have to take 3x to the 3 halves. We're going to divide that by 3 halves, right?
Yep.
Minus, and we're going to add 4/4 to this,
7/4.
right?
Yep, 7
So
fourths.
x to the 7/4 over 7/4 plus c, correct? Okay. So what happens when you divide by 3 halves? You end up multiplying by
By
2 over
2 thirds. So
So
what
you
happens to
do
the 3's?
They cancel.
Cancel.
They cancel. So you get
2x to
2x.
2x to the 3 halves
Yeah.
minus 7x to the 7/4 over 4, right?
Here's it 4x to the 7.
I take 1 times 4/7.
What?
I take 1 times 4/7.
Oh, you're dividing, I'm sorry, it's 4/7.
Okay.
So it's 4x to the 7/4 over 7, right? Plus c.
Could you have 4 over 7 x to the
4/7 x to the 7/4, yes.
Okay.
Same thing.
Alright.
Alright, now let's try this one. What should you do first? Factor.
Should we bring it up to a negative 7?
I would divide each one of them by this.
Oh, separate.
So I would say, yeah, so I'd say 3 halves, x to the -3, right?
Yeah. Minus
Minus
x to the negative 4
x to the -4,
plus 7 halves
X to
to the
negative
negative
6.
6.
alright? Now take the derivative, oh, by the way, this should have been f of x here, back here, I wanna make sure that we label correctly as the original function.
And you raise it one, so it'd go from a -3 to a -2, right?
Mm-hmm. Yep. Did you hear that? When you raise it one, you get a +1. Right?
Do we have to put them back below, or?
At negative exponents, yes. Should be good. All I did was simplify this. So I have not taken it. So, the original function, right? I'm gonna take 3/2 x to the, and I'm gonna raise it up one, right?
Yeah.
Divided by,
Negative.
is that right?
Mhm.
Then I'm going to subtract, and I'm going to take x to the -3 over,
Negative.
and then I'm going to add 7/2, I'm going to divide by
-5.
-5, x to the -5, and then plus c, is that correct?
Mhm.
Now that is by far not simplifying. Simplifying might be the biggest problem here, okay? So, if I take 3/2, this would be times -1/2, right? So it's negative, right? And I believe it becomes 3/4, right? Okay, but where does the x to -2 go? It goes down here, doesn't it?
Yeah.
Because this is a negative exponent. Do not leave it as a negative exponent. Do not leave it as a negative exponent. Okay? And then this is a -3, right? So this is a plus. A minus, right? What?
It's plus.
Yeah, it's plus.
1/3 x,
1 over
X cubed.
3x to the third, right?
yeah.
Questions? So then, we're gonna multiply by the reciprocal, which is -1/5. So this is negative, right?
-7.
I believe it's 7 over
10.
10.
10,
X to the fifth.
x to the 5th, right?
Plus C.
Plus the good old C.
Plus the good old c,
I've got this.
right?
Rough talk, well.
Pretty easy to forget the c, isn't it? Yep.
On number 4,
Yep.
where it was in the radicand, is it alright if we don't put it back in?
You know, it probably should be, that's a great question. It probably should be 2, and that can be simplified, right? Since it started in radicand form, it needs to end there, doesn't it? So this should be x times the square root of x minus 4/7 x to the 4th root of x to the 3rd, is that right? Plus c.
Where do you get that? Okay, where'd you get the
Number x to the 7.
What's that? This one?
fourth row x to the 7th, right?
Well,
How'd you get x to the?
He factored in the x because
Okay.
there's 7 of them.
Oh, I see it.
If you get x to the 7
Oh, I see.
fourths, yeah, that means there's 7 of
So
them.
you take x to the 4 over 4
So
out.
it takes 4 of them to make a perfect 4th root, right?
Aha.
And so then that leaves 3 inside.
I see. Okay,
Yeah.
thank you.
Yeah. Thank you, Mr. Dockweather.
Yeah.
Should be
I would have too, but I
Good
don't
to
know.
okay.
Now we don't have an excuse.
Meet you behind the woodshed.
Bring your crutches.
Yeah.
There you go.
Oh, wait. There's another one?
Yep. We could be 1 second of looking at. I'm already stressed. Oh no, this ain't terrible.
Yeah, famous last word.
Shh, Weston, I'm being positive.
This should be f prime of x, kinda getting rid, kinda missing my notation there.
Can we leave that as an improper fraction?
Yes.
What do you mean like that is improper?
What do you mean?
15/2.
Yeah, boss. Weston, it's over x to the 1/3. When you put it up to the top, it'd be 5x to the negative 1/3.
Yeah.
Yeah, minus 6x to the negative 3/4. Okay. So then you have 5x to the 2/3 divided by 2/3.
How did you get,
How did you get?
how did you get 2/3?
You gotta add 3 over 3.
You gotta add 3/3 and one negative
It's
1/3.
negative, boss.
Right?
1/4.
Right?
Yeah. I think so. Let's see. I'm not gonna forget that.
So this would be 15 x to the 2/3 over
2.
2, and can I leave it like that?
Yes.
Yes, because it didn't start in radical form. Right? Minus 24,
Yep.
x
X
to
to the
1/4.
Let's see. Handy dandy.
All right,
Builder.
you okay, Gavin?
Yeah, I just messed up when I did my fraction.
Okay, would you turn back to page 152? 152. 152 is the derivatives of the trig functions. So let's, if I give you the derivative, I want the antiderivative, right? Okay. So what do I do here?
What derivative? Cosine is the derivative of sine. So I don't know what I do with that actually.
So what do I do here? Well, this would stay 7, right? What okay, what is cosine the derivative of?
Sine.
It's the derivative of sine, so this becomes
Sine.
sine of
Theta.
theta. Minus 3, okay? What is sine the derivative of?
Oh, nothing.
Well, the derivative of cosine is
Negative sine.
a negative sine, so what do you think the derivative of
Negative cosine.
negative cosine is?
Sine.
Positive sine. So this would be times 3 times the negative cosine theta, correct? So to simplify, if we say 7 sine of theta plus 3 cosine of theta plus c.
Oh my.
I didn't even get to write that problem.
Wait,
Don't we have a cheat sheet card?
Nope, not for the derivative.
let's not be throwing out answers here.
You guys are just
We're a mess.
Didn't we make one though already?
That was last year.
How
That was
did you
last year.
get negative cosine theta there?
Okay, right here?
Yeah.
The derivative of cosine, right, is a
Negative
negative
sign.
sign.
But is that
That's a
negative?
positive sign.
So you gotta make it a negative cosine.
If it's the derivative of a negative cosine, then it'd be a negative of a negative sign, which would be positive sign, which would, that's how we got it. So we put that in actually. What's that?
Good God bless calculus.
He did. Yeah. If I hear these comments on the video, I'm going to. There's gonna be some.
What did you say?
Alright, I don't wanna know what he said. Alright, so we're gonna stop there, alright? I want you to look at page 279. I'll do the others tomorrow. Page 279, we're gonna look at numbers 1 through 15. We're gonna end up doing 19 through 34 also. However, 1 through 15, kind of what you're gonna concentrate on for tomorrow. There'll be some. It is not due. I will add on to it the rest of them, but just so you know. What's that? Oh.
You want to stop it?
Yeah. Thought you tipped it over.